In the present lecture, we have to study the experimental determinant of Young's modulus of the given bar by forming elliptical fringes through Cornu's method. The aim of the experiment is known to you, determination of Young's modulus and Poisson's ratio of the given bar by forming elliptical fringes. These are all the apparatus we required: sodium vapor lamp, transparent glass beam for 45 degrees inclination, experimental beam, which may be glass or any other flexible material, plano-convex lens of long focal length, traveling microscope, excisor type, two knife edges, weight hangers, and slotted weights. The theory is also known to you. We have to form the Newton rings first, and then if the load is applied, the Newton rings are changed into elliptical fringes. See the procedure. The width, thickness, and distance between the weight hangers and the closest knife edge are measured with a vernier caliper, a screw gauge, and a measuring scale respectively. The beam is positioned symmetrically on the two knife edges, making sure that the distance from each knife edge to the suspension point is equal on both sides. With the introduction of dead load, along with the precise maintenance of the glass plate at an angle of exactly 45 degrees, results in the formation of Newton's rings, which can be observed both with the naked eye and under a microscope. To transform the concentric circles into an ellipse, it is necessary to apply an appropriate load, say M1. This results in a variation of radius of curvature in both the longitudinal and transverse directions. After setting the elliptical pattern, position the microscope vertical cross wire at the nth ring on the left or right side. Next, count by threes and move the cross wire to the n plus 21st dark ring. First, take the microscope reading for the n plus 21st dark ring. Then record the readings for every three dark rings in decreasing order until you reach the nth ring. Next, move the vertical crosswire of the microscope to the nth ring on the other side and take readings in increasing order until you reach the n plus 21st dark ring. Similarly, we need to take readings for the transverse mode. For this mode, we should place the vertical crosswire at the top of the n plus 21st dark ring and then move down in steps of 3 rings to record the readings. The same steps are followed for another load, say M2. This is the formula we have to use to determine the Young's modulus. Q equal to 12 into M2 minus M1 GL divided by BD cube into 1 by R L1 difference or 1 divided by R L2. Here RL1 represents radius of curvature in the longitudinal mode for mass M1. RL2 denotes radius of curvature in the longitudinal mode for mass M2. L, the distance between the knife edge and the nearest position of suspension. B, the breadth of the beam. D, the thickness of the beam. G, acceleration due to gravity. In order to find out the radius of curvature, we have to use this formula: x square n plus m minus x square n divided by 4m lambda. Here R suffix L is our radius of curvature in longitudinal mode. X suffix n plus m denotes diameter of the n plus mth ring. X suffix n represents diameter of the nth ring. The ratio of lateral contraction to longitudinal elongation is called the Poisson's ratio. The Poisson's ratio is obtained by this formula. Here RT1 represents radius of curvature in the transverse mode for mass M1. RT2 denotes radius of curvature in the transverse mode for mass M2. Now this is the observation part. These are all the traveling microscope readings. First, we have recorded the reading for the longitudinal mode with the usage of weight 550 grams. It is 550 into 10 power minus 3 kilogram. This is for nth ring, MSR, VSR, total reading. This is for left. For the right, we have observed these readings. Then the difference between these two total readings is our x suffix n, that is diameter of the nth ring, is the square value. In the same manner, we have recorded the readings for n plus 3, n plus 6, and so on. Then in the last column, we have recorded the difference for 15 fringes, x square n plus m minus x square suffix n. Say n plus 15 minus n, this much. Then n plus 18 minus n plus 3, the second reading. N plus 21 minus n plus 6, the third reading. The mean reading is 0.07957. This is for M1. The longitudinal mode for M2 we have recorded this table. So these are all the readings corresponding to the second mass. See, for the nth ring, this is the diameter. This is the diameter square. These are all the readings for all other cases. Then x square n plus m minus x square n for 15 fringes is given in the last column. N plus 15 minus n, x square n plus 15 minus x square n is the first reading. Then n plus 18 minus n plus 3, second reading. N plus 21 minus n plus 6, third reading. Then we have taken the average of these three. Now, the transverse mode also we have recorded the readings. For the first mass, these are all the observed readings. And for the second mass, these are all the readings. Now we have to go to the calculation part. First we have to find the radius of curvature in the longitudinal mode for the first mass. For that, we should take the x square n plus 15 minus x square n value. See, go to the first table. Longitudinal mode 0.07957 is the value. See here, that value is given here into 10 power minus 4 meter. Then 4 m for 15 fringes, you have made this calculation. So 15 lambda 1593 in 10 power minus 10 meter, that is wavelength of sodium vapor lamp. So this is the value of RL1, radius of curvature in longitudinal mode for the first mass. This is 1 by RL1. The same manner, we have reached the value of RL2. Then this is 1 by RL2 value. For that, we have used the second table. Say 0.085178. That value we have used here. RL2. Then 1 by RL1, difference 1 by RL2 is this much. Yes, we have to record the difference, not minus. Then go to the transverse mode, find out the value of radius of curvature. The transverse mode for the first mass, that is for 550 gram, is 1 by RT1 value. And for the second mass, this is our T2 value. Then finally we have reached the value of 1 by RT2. This is 1 by RT1, difference 1 by RT2. Then using the formula Q equal to 12 into M2 minus M1, GL divided by BD cube into 1 by RL1 difference 1 by RL2. We have arrived at the value of 0.74 into 10 power 10 Newton per meter square. This is the Young's modulus of the given bar. Actually, we have used the telescope scale so that we have reached such a lower value. Then the Poisson ratio is obtained by this formula. If you find the Poisson ratio, you had the value of 0.1964. Usually you may get the value less than zero point 0.5. Here we have obtained 0.1964 as Poisson ratio. So in this way, we have achieved the values of Q and sigma. That's all about the Cornu spiral experiment.